I was talking for first and second law, and the feedback I got that there are a lot of confusion in last class, right? Yes or no? Yes? How many are having confusion? Any hands so that I can repeat? Only one I can see. Two. Okay, there are so many. So that's what you guys are generally very afraid. I don't know why you are afraid, because I don't penalize and all those things. Even if you are more willing to learn, I am willing to teach. But the thing is that you should be very much honest what you want to learn. So I'll just go through quickly what we have done, and then I'll proceed forward. We had du equals to TdS minus P dV plus mu dN. I think all of you understood this one. And which is what? Du equals to U at S V N. And you also found out this is the homogeneous function. This is homogeneous function, which is what? And that is also first order. Homogeneous function of first order. You had, you can write U equals to lambda S, lambda V, lambda N, which is lambda U S V. What does it mean physically? Physically it means that this SVN and this SVN are extensive variables. That means that depending on mass or the number of loops. It says that if each of these properties, entropy, volume and N, are increased by lambda times, lambda means 5 times, 6 times, 7 times, the internal energy, which is a function of SVN, it will also be increased by lambda times. It's nothing, very simple. I have in a system, I have the entropy, volume and number of loops. Each are increased lambda times. My property, which is dependent on both all these properties, will be also increased by lambda times. Very simple. And that's so much of mathematics involved, but if you look at philosophical perspective, it is nothing. It is also increased by lambda times. And that's why it is called as homogeneous function of first order. If it is lambda squared type, second order and so on. So from here we found that from the partial we know that if y equals to y at x1, x2 up to xn, we all know that dy equals to say dou y by dou x1 dx1 plus dou y dou x2, which is here x2 to xn, here x1, x3, xn, dx2, and then dou y dou xi xj not equals to y dxi plus net term. So this is the generalized term. So this what are kept constant? When if it is dx2, except dx2, everything is kept constant. So we can write this as summation I equals to 1 to n dou I dou xi I not xj, where j not equals to I dx. This is equals to t. This formula will be useful later. We just try to. So this is the generalized function, and from here we can see there are only 3 variables. So this is acting like your dou u by dou s at fixed v and nv, and p equals to dou y by dou v at fixed s and n, and this is dou u by dou n at fixed s and b. So you got, so up to this everything is quite clear to you, right? So you got dou u by dou capital S v n equals to t, dou u by dou v s n equals to minus p, and dou u by dou n at s v equals to mu. Everything is clear so far. Everything was perfect. And then we introduce the concept of a specific variable. Right? What is a specific variable? Any of the extensive properties we take. What temperature? Temperature is not an extensive property. Intensive property. Pressure is intensive property. But entropy, internal energy, volume, they are all extensive property, and consequently, as a consequence, we can actually have specific properties for those. So we can have small u, which is u by n, small s, we can have s by n. Small v, we can have v by n. And remember that everything, whenever we write a variable for thermodynamics, what I suggest that try to write all the independent variables initially, because if you are not comfortable with the calculus, better to write the independent variables so that we can actually apply the chain rule of differentiation. Otherwise, we will be lost. So, for example, when you write this, it is nothing but u hat. What's the function? What is that? Mos. Just one hand, please. U hat is what? Function of? Any other answer? Any other hand? Yes, sir. Why? I don't know why you told like this. If I say x is y by z, what should I write? Function of y and z. Sir, don't complicate your life. It is very simple. There is no point to complicate the life. Okay? And then you can write this u hat, u, we know that. That is there. You can go on writing that. But first is u hat is u of n. Similarly, small s is small s hat, s n, and small v hat, v n. Right? And then what we wanted? We wanted to prove from here du equals to tds minus pdv. We showed that. I don't want to say we wanted to prove. We showed that. And in order to show that this t is what? T has the term which is dou u by dou s at fixed v, and this is the term dou u by dou v at fixed small s. Having said that, you have to prove dou u by dou s vn equals to dou u by dou s v. So you need to prove dou u dou s vn equals to dou u by dou s and small v. That means what? Change of one extensive property with respect to other extensive property is equals to change of the specific property for the same property corresponding to that with respect to the change of other specific property corresponding to that. What I am trying to say here? Change of first specific property with respect to second, change of first extensive property with respect to second extensive property is equal to change of first specific property with respect to second specific property. Please write down. If you look at me, that's it. It is not there in any of the books in the market. So change of first extensive property. Please write down what I say, because most of the times I won't write. If you are lazy, that's it. You are gone. I am not responsible for that. Change of first extensive property with respect to second specific extensive property is nothing but change of first specific property with respect to second specific property. How to prove that? So in order to prove that, we actually use the so you have to express. So how to attack this problem? That is another conclusion. Dou u by dou s vn. Remember that we need to have small u. We have the relationship which is u equals to n into u. So put it here. At least you got small u here, but this part is still remaining capital S. We need to have small s, otherwise your proof is not done. Okay? In order to do that, you have to write it as u hat SV. As I said, in thermodynamics, whatever variables you have to write the corresponding independent variable. And this is, you have to write B and N, and what is called a constant. If you don't write, you will be lost. In that case, I can say this step is complete. Otherwise, my step is not complete. Your V and N, they are kept constant, that's fine. N is, of course, kept constant, doesn't matter. U is, you have SV. Okay? You can proceed further. N is kept constant, N is coming out. Dou capital S. U hat SV. Vn. Next step. dou U, dou S, Vn, N, dou S, U hat SV, Vn. And here is a chain rule of differentiation. Here V is constant. Okay? So we will be operating only with S that we have discussed. If we have function of xt, yt, if you want to take df by dt, we have done it in calculus 10 plus 2. What is that? Dou f by dou x, dou t plus dou 1 by dou y, dou t. Am I correct? You have done the calculus, right? 10 plus 2. Dou f, dou x, dx dt plus dou f, dou t, dou y, dou t. Is it clear to all of you? You have done it. Parametric calculus. If you don't remember, go to 10 plus 2. Not even BTech first year mathematics. 10 plus 2 calculus book. You had calculus in plus 2? All of you had? Anybody said no? Okay, everybody was having calculus. So that means it is quite known to all of you. And that's it actually acting as this SNP. So now you can see that. So what you can write, this you can write as dou S. So small s, so you write this and now you can see small s doesn't matter. It is dou U hat by dou S, dou S by dou S. So it is actually coming dou U hat by dou S only. Nothing, doesn't matter. It will be actually important when we will be doing the chemical potential calculation. This part is clear, this part is clear. What is this part? This is also dou U hat, dou S. What is this S function? S is the function of S and N. So instead of putting this, that's what I'm saying. So when there is a function of S and N, you can see that it should not be the function of D. And I did it that if you look at equation of state, go back to your class 1. Equation of state, when I had the formula for T, P and all, and T was the function of USB, how it came? How it came? Because T equals to dou U by dou S at fixed B, N. That means what? At the denominator, if you look at, it is coming SBN. That's why T equals to T hat SBN. The same concept here. S is the function of S and N, and that is from that. So, when we say B and N, so B should be going here and N should be going here. Am I correct? Because we knew that from equation of state, T hat SBN. Why? Because T equals to dou U, dou S, Bn. This three I am taking. Same thing here. And I know that S is the function of S and N from here. So I can write this. We have B. B should be coming here. And that's it. B is coming here automatically. And this B is nothing but small b. Okay? Because capital B is this small b, and N is also B. So we have dou S by dou S, dou S by dou S capital N. What is that? It should be coming as? What will be coming as? 1 by N. So dou U hat dou S B, which is equals to T. Funda is there, is swapping business. And that's why I wrote like this. If you don't write, you cannot do swapping business so nicely. How this constant should be swapped from here to here, we can easily see the picture. Right? Here it N won't come because the function of S and B, so only B is coming. Here B won't come, this function of S and N. Funda is clear? Same way we can do the other formula. Is everything clear? Any doubts? Is everything clear? Next is the chemical potential. The second part I am not going to prove, that is dou U by dou V at fixed S. equals to dou is small u by dou v at small s equals to minus p. That you can prove the same way. Next is dou u by dou n at fixed SV. You have to write with respect to the specific properties. Remember that change of extensive property of 1 with respect to change of specific property of 2, we can write change of extensive property 1 with respect to change of extensive property 2. If you do that, a lot of interesting things will come out. And why you need to do that? Because if you go to the specific property, your life is simple. You will reduce one variable. You don't have to use n. So that's why when you have extensive property, it's better to write a specific property. In that case, the change actually is important because all this intensive property you can express in terms of the ratio of this change of specific property. Remember that T is nothing but dou u by dou s at fixed b. Dou u by dou v at fixed s, and P is dou u by dou v at fixed s. And if you look at this intensive property, they're expressed in terms of the change of extensive property with respect to the other extensive property. So, in that case, any of the intensive property can be expressed in terms of the change of specific property with respect to other specific property. Am I correct? Yes or no? Yes? Okay. So, here, same thing, we can express this as with respect to, if you look at, we just look at what we want to do here, dou n u hat, which is the function of s, b, s and b. Then next step, remember that here n and u both are variables, and n is independent variable, so there is no point to write n is a function. It is independent variable, okay? N is independent variable, but e is dependent variable. So in that case, since s and b are constant, we have to treat as a multiplication rule. So it is n dou n u hat sv here plus u hat sv dou n sv. I am going by very basic rule. All steps I am showing you. Just see that. And this is equals to 1. So we have n dou n. Now look at this dou n is there. My actual thing is actually that function of x1 t, x2 t, you have to just treat it as a Bible. Your Bible of calculus, your Bible of thermodynamics is this one, x1 t, x2 t, and you're always taking differentiation with respect to t. If you know this formula, your entire life, 50%, 60% life is solved. If you don't know, if you are confused, a serious problem. Okay. So again, you have to express this as a function of, this s is a function of, pardon? Capital S and N. You are right. S is a function of capital S and N. V is a function of capital B and N. S V plus you have S V. Okay. So now my formula is there, right here. What is that? What you can write? N. If you look at, what's the next one? I want you to tell me. Remember that here S and V are constant. So here if S is constant, you don't have to take anything because dou S will not come. Even if you want to write, you can write it out, but eventually it becomes 0. Or if I want you to write fully. How to proceed? How to proceed? Dou n. What are the terms? I want you to volunteer. Who will volunteer? I am giving you time. If you don't volunteer, you will not. First you try this, then this one. Nobody can volunteer? So why I am teaching and what I am teaching, I don't know. After so much, if you cannot say, I am saying I am failure. Maybe nobody taught me this subject. That's what I have learned by my own. Maybe I should not teach, you should learn by yourself. Then I should stop taking the class. Yes, sir. Please write small or capital.
Capital.
Dou u capital.
U small.
Yeah, please, hear that.
U hat.
Dou small u hat.
Dou small U hat
Dou small u hat.
by dou capital S. Dou small S.
Dou smallest or capital S?
Small S.
Okay. Then
Dou small S.
why it is and then dou s. And as I said, I don't like if you prompt. He only volunteered. If somebody else wanted to do that, you can raise the hand. I don't want the class to be a fish market. I'm sorry to say that. Next. Why we are writing like this directly? You could have written dou u hat by dou s by n, but this s is constant. Right? Okay. Next is
Dou U hat by dou V.
dou u hat by dou v. Then
Dou V by dou N.
dou v by dou n. Job is done. And S is what? If you are really confused, S is, you know that, function of S and N. This V is the function of V and N, which is SV. Complete the step. U hat is the function of S and V. Right? So when you have, and this dou u hat dou S, when you write dou u hat by dou S, it should be function of V. It should be V here, because u hat the function of SV. Now no other variable should come. Should not write S. It doesn't make sense. If you are confused, go to the equation of state. Equation of state says that T equals dou u hat by dou u by dou S by V at fixed B, and that says T is the function of USV. Okay, so it should be V. So other term will be dou S by dou N. It should be. Am I correct? This step. Agreed or not? No, you don't agree. What is the function of S? As I said that this S is what the function? S is the function of V. The small s is what? S by n. It says that S at Sn, and you cannot say V. Sir, I am sweating out. So if the function of n, so if it is I write dou S by dou n, the thing should be consequent as capital S from the equation of state. You remember equation of state? Please go through. I don't think you have gone through the notes. So please come prepared to the class. Otherwise, please do not come. You have not come to IT Madras to play. You have to come here to learn something. If you don't prepare, please don't come, because I sweat out when I teach the class. Did you understand? Then if you understand, please tell me the next step. Dou u hat by dou v. U hat is a function of what? U hat, small u is a function of what? Dou u hat by dou v. If I write dou v, then what will be the complete? How to complete this? Yes. You know that you are not here. I don't think you are reading anything in your home. No, you are not. I am not getting any answer. If you argue with me, you are murdering yourself, your academic career. Then dou v hat by dou n, how to complete it? I am asking you again. This entire term is constant SV. I wrote S. What else is remaining? You are not studying anything. I am telling you, you are in a serious situation. This entire term, constant S and V. Already S has appeared. What is left? Yeah, the same thing, small thing you are not able to understand. Go to the kindergarten level. And this V hat, don't say V, it is V equals to small v hat, capital Vn. So capital V is there, it is actually here. So it says that, so this V is constant only. So next step is dou u hat, dou S by V, it is already proved as T, right? Already proved as T. We have done it. Dou S by dou N at fixed S. Dou S by dou N at fixed S. How much it is? What is that? Minus S by N square. Capital S by N square. You are not writing capital because you are so lazy. You don't want to write there. If you don't tell, you do mistakes. Minus capital S by N square. Next is plus dou U by dou V at fixed S. What is that? Yes, sir, last bench. You are not, if you do like that in the class, you are not participating in the class, you are copying not, no sir, please don't argue with me, I am sorry sir. No, if you are, I think serious problem, everybody else is able to answer, you are just not looking at the board. Yeah, if you are trying to do that means you are not coping up in the class. Serious problem. Please read it, please, I am telling you, otherwise you will have a serious problem. You are not reading it. Okay, so dou U by dou V at fixed S, what is that? Minus P, yes sir. And this one, if you look at dou V by, so we had V equals to capital V by N, dou V at by dou N at fixed V, this V is constant but this is variable. In taking this, it is nothing but minus P by N square, and this is minus P by N square, and plus U hat, and that's it. This is coming, and this will go to small s, this minus N square, and this one will be going, so it will be minus P, this is coming small v, and you are getting T minus Ts plus P small v and minus U, and this dou U by dou N is nothing but V. That's the way one can do in class. Did you understand the swapping business? It's pretty straightforward. So whenever you have the partial and you have this, when you take it out, you have to put something here. Always try to see what is the original function. Is the function of S and B, so only B should appear, no other things. You have to feel thermodynamics in your heart. If you don't feel, if you want to mug up, that's it, you are completely lost. Okay, so all those things should be coming. So we know that U equals to U hat. We know that U equals to U hat SBN. Okay, so and small u equals to small U hat SB. Already been proved. That means when you have dou U by dou S, you are lost. What to be done here? Of course, consequence of this combined first law and second law is only should be appearing V. Otherwise, if you have something else, you cannot define this quantity as something. Only then you can define this quantity as temperature. Is it clear to all of you? That's what. So when I have these two constants, how to pick up? The picking up from the base of the definition of thermodynamics combined first and second law of thermodynamics. And that's what actually I am doing it. And same thing for the any partial derivative. You just see what is the original function. If I have, so these concepts are starting to be very much clear. If I write dou F by dou Y, it is wrong unless I put something here like Z or U. In that case, I have to know actually what is my function. What is that? It is U or Z, and based on that I put it. And that's the way the swapping business is done. Is everything clear to all of you? Okay, so that's what it was done. I think this concept, if you make it clear, the rest of the part of thermodynamics is very, very straightforward. So let's go back what we are discussing with. So I think we have cleared out all the equation of state and Gibbs-Duhem relationship. We have done it. One interesting thing actually I asked last class. We have done some problem 1 by t or something, and we have shown that which is zeroth order homogeneous function, right? Some problem was there, right? Last class 1 by t something like that. Zeroth order function, some order homogeneous function. We have done, right? Yeah, so S equals to S hat UBN was given, and I asked you to do that. But what I actually wanted to say that when you write T equals to T hat SBN, can you prove directly from here? That's what I was asking last class. Can you prove directly that T is the homogeneous function of zeroth order? How? Yes, madam. Yes, proceed. No, what is my rule? Don't say dou. Dou should not come in picture. What's the definition of homogeneous function? Do you remember? T is lambda s, lambda b, lambda n should be equals to lambda to the power k, d s b n. What is this k? 0. Why? Because we know that T equals to T. That means what? T S1 V1 N1 should be equals to T S2 V2 N2 of the particular system, because T is the intrinsic property. So in that case, what actually happens? S1 equals to lambda of S2, V1 equals to lambda of V2, N1 equals to lambda of N2. Now you can see that it is coming lambda to the power 0, so it is a homogeneous function of 0th order. So that problem was given, but you can do that based on the simple concept, but there is a cross verifying or benchmark. Okay, so we did Gibbs Duhem relationship. What we have done for Gibbs Duhem? Gibbs Duhem relationship, which is du TdS minus PdV plus mu dN. Okay, and from here we have proved dT equals to minus SdT plus VdP. Have you understood this proof? Do you need me to repeat? I don't think you want me to repeat. Do you want me to repeat this proof? Yes or no? Everything is clear. This proof is very clear. Nothing is there in calculus. And because we all know that from Euler's theorem, or we have proved from the nu that u equals to Ts minus Pv plus mu n. We have done from Euler's theorem, right? And from there you know that if you take derivative differential from here, this already there, so other part will be coming to 0, and then if this space express in terms of specific property, you get this. Yeah. You wanted to? Okay, you said something. Okay. So dg equals to minus SdT plus VdP, and this is quite straightforward, this proof. As I said, the combined first and second law you can express in two ways. One is energy representation, another is entropy representation. So if you look at entropy representation, can you get the same expression? That's my question. Is this expression valid? Is this expression valid if we use entropy representation? Is this expression valid if you use entropy representation? What is entropy representation? Let me look at it. Entropy representation of combined first and second law. Entropy representation of combined first and second law, which is what? ds equals to, any volunteers? Raise the hand.
1 by T du
1 by T du
plus P by T
plus
P by T
P by T
dV
plus or minus? Plus. Minus what? Minus mu by T? Yes. What is corresponding Euler's law? You have learned Euler's law, right? Euler's theorem. from Euler's theorem, what is the expression of S? In fact, from here we can see that S equals to S hat U V N. Okay? If I ask you dou S by dou N, how it is related with dou S by, sorry, I should not put it that way. Dou S by dou N, how to express in terms of specific values. What we have done in the previous calculation, that means if I want to do dou N S hat U V, you will get the same expression what you get from Euler's theorem. I want you to go home, try to prove what you get in the Euler's theorem by this approach. If you do that, you will learn more. But now apply Euler's theorem and let me know what the expression is. Apply Euler's theorem and let me know the formula. What is that? Devan, any clues? You are hiding from me. If you hide, no, you are just looking at there, you are not looking at the board. Many people are looking at the board. Look at the board, you can get the answer. If you know the Euler's theorem, I don't think you know the Euler's theorem. You have not studied. No, this is not Euler's theorem. Sorry. You don't look at his notes. Euler's theorem, you should not be looking at the not ds equals to the function of x1, x2, xn, the homogeneous function. What is the Euler's theorem?
Sir, f is the function of x1, x2, x3, xn. Then it will be del f by del x1 into dx1 plus del f by del x2.
In the summation form?
Sir, del f by del xi into dx.
Not del f, dou f by dou xi at xj dxi equals to?
Sir, dou f by dou xi.
What is right hand side?
Right hand side would be, sir, dou f by dou xi.
No, right hand side is n into f. Okay? And n is the order of the homogeneous function. Order is 1, so n equals to 1. We have not learned anything there. We are not studying. Okay. Who can volunteer this homogeneous function? This is, yes, madam. 1 by t into capital. Yes. Plus p by t capital B minus. Yes, done. And this 1 by t is acting like your dou u by dou s by dou u. This is acting as dou s by dou b at fixed n and u, and this is acting as dou s by dou n at fixed u v. And that's the way Euler's theorem has been done. And this can be proved from here. I want you to show me the proof next class. What we have the same way, the calculation of G, the same way you can actually do it. Can you do it? Answer should be yes, you can do it. You have done it already. So now what is the given formula here? Quickly tell me. You have to take derivative differential here, and you know this is there, and some part will be coming to 0. Do the calculation, give me the answer. Here you got dg, we can also write this as d mu. Both are same. I want you to compare. If you have entropy representation, will you get the same expression as d mu? I want to see that. I want to see that. I want to see that. Take the differential. It's so straightforward. Take the differential, get it. Take the differential and get it. Take differential, give me the answer. It is so straightforward. It is so straightforward. Take the differential, get me the answer. Can you take the differential? Who can give me the first step? Madam, can you give the first step? If you take differential ds, ds equals to 1 by t, then u, differential of 1 by t plus p by t d capital B plus b differential of p by t plus minus mu by t dn minus n differential of mu by t. So straightforward. You are taking so much of time. I don't know what level of mathematics you are at. I am really confused. Now you can see these terms are already there. So those terms will be going off. 1 by t, p by t dv, and mu by t, this, and this will go with ds. You can see that u differential of 1 by t plus v differential of 1 by t minus n differential of mu by t equals to 0. So what is the analogous formula of entropy representation? Entropy representation, analogous formula. Entropy representation analogous formula is what? You should be multiplying with capital N to get the specific variables formula. What is that? You are not studying anything. That's a problem in the home you go and you just enjoy life. I can get answer only one or two guys, maybe madam and next to madam. Sir, yeah, I can only depend on only two people, right? Except maybe three. Three people I can depend in the class. Others are not studying. Others I cannot depend. Yes, sir. Any answer? Please tell capital V or small v.
Capital V.
Capital V I want in terms of specific variable. Yes. Nobody can get? Yes, madam. Small u, yes, madam. D of 1 by t plus, yeah, d of, yes. So it is d of, am I correct? So you are not getting same formula. You are getting different formula. So in all the textbooks they do energy representation, and that's why you get simple formula. If they do entropy representation, you get this kind of formula. So this kind of set of function, as I said, called Massive function. The Massive set, you can actually go by that and you get this type of formula. Then question is, why books are not using this? This will give the same result if you want to analyze by this entropy representation, but calculation will be cumbersome, complicated. You always want to go by easy path because you get the same result. That's why books they don't discuss. But you all should know that entropy representation should lead to this formula. Now, before going to much further, we have learned enough of coming to my combined first and second law of thermodynamics. Combined first and second law. We know that U had U equals to U had SVN. That means what? Internal energy, the function of entropy, volume, and number of molecules. Can you have any meter which will measure entropy? No. There is nothing called entropy meter. Can you measure volume? Sometimes yes. Can you measure moles? So that means what? Which are the things you can easily measure? Which is intrinsic property like temperature, pressure. You can easily measure. My question is, can I express U as function of temperature and pressure? Then in that case it's very straightforward. I know temperature and pressure, from the particular function I can get U. Can you do that? This is important. This from here, as a practicing chemical engineer, when you go to a plant, you cannot measure entropy. Volume also not measuring is not that straightforward because you have a complicated cavity, you have to know the diameter and all. It's very cumbersome process. Number of molecules is cumbersome. So in that case, what will be the answer? Sir, I cannot measure internal energy because in different variables I cannot measure. That is not the answer. Answer is, can you express U as a function of temperature and pressure? In that case, can you measure internal energy? Let's proceed further. If you look at dou U by dou S at fixed Vn, which is temperature, dou U by dou V Sn, which is minus pressure. Very interesting. That means first derivative is giving me temperature and pressure. These are the intrinsic properties which you can measure. That means what? if I have a function yx, this is y equals to fx, the slope is dy dx. That means if I keep b and n constant and plot u versus s, the slope is temperature. Keeping b n constants, if I have u versus b plot, s and n constants, the slope is minus b. Very interesting. Question is, can I express u as a function of slope? Let me tell you what I am trying to say. I will tell very simplified way. Yx, this line equation is y equals to mx plus c. If I want to replace x by m, can I write y versus m? If I say, if I give y versus m, can you get back here? No, because all has same m. Which line will be representing? I want this particular line, and that depends on intercept. So if I give y versus m, I am not getting unique solution. I may be representing any of these parallel lines. That means, what is the proper way to have this exactly this line on what variables you represent such that you get the exact same line? You know that y versus m is not giving. This line represents any of this line. Because all the parallel lines have the same m. How to fix? Intercept. Intercept is fixed. For different lines we have different intercept. So what will be the exact replacement if you have m here? Yes sir, excellent. C. That means if I have y equals to y versus x, if you want to replace as a known property, which is C, right? That means if you want to express you have this there, you want to express in terms of temperature, the slope. This will not be u anymore. This will be something called C. So if you want to measure this property, the function of temperature and pressure, this property will be changed to some other property. How to get that property? That is obtained by Legendre transformation. That is obtained by Legendre transformation. That I am going to discuss in the next class. Thanks for kind attention.